All right, so now we're going to do the online modeling lab 12, the monopolistic competition model. In the monopolistic competition model, there are no government entrance barriers. A perfectly competitive firm can become a monopolistically competitive firm if it can successfully create an artificial market barrier via incredible marketing, product design, innovation, customer experience, etc. The better this firm is at these tasks, the more it can tilt consumer demand in its favor. If it succeeds at this, it is faced with a downward sloping demand curve. This allows a perfectly competitive firm to become a monopolistically competitive firm. It can then create an artificial scarcity by restricting output to push prices up its demand curve. Essentially, its efforts have created a monopoly, which consumers voluntarily accept and its rivals find difficult to penetrate. Okay, now down here we have the marginal cost curve of some firm, which has identical production to a bunch of other firms, right? If it has incredible marketing, product design, innovation, customer experience, etc., it can tilt the demand curve, right? And this demand curve has a slope to it, right? But if this firm is not very good at any of these tasks, then the product it sells is like a commodity, easily replicated, duplicated. The same goes for its customer service, right? So it ends up being a price taker, not a price maker. And so a firm that's not at all good at this stuff would be a 1 on a scale of 1 to 10. Now, such a firm, again, would be a price taker, not a price maker. So this is the market price. And so this firm is essentially faced with perfectly elastic demand that has zero slope, right? You can see that right here. The demand curve is P minus 0 times Q. So the demand curve has zero slope. So 0 times Q is 0. And 15 minus 0 is 15. So the demand curve is this flat line at 15, right? And then this is the marginal cost curve. Now you can also think of this flat demand curve as its marginal revenue curve. Because remember, a firm's revenue is price times quantity. And here the price taker has no control over price. It takes the price as 15. So its revenue is 15 times Q. And marginal revenue is the slope of revenue. If revenue is 15 times Q, the slope of 15 times Q is 15. So marginal revenue would be 15. So you can think of this as the firm's marginal revenue curve, right? And firms maximize profits where they increase output until the marginal cost just equals the marginal revenue. So this will maximize the firm's profits right there, right? So let's hit enter. Okay, now down here, if the scenario in figure 1 represents the situation the firm was faced with 5 years ago, what did it do 5 years ago? Well, it chooses its output again where marginal cost equals marginal revenue. And I have a Desmos model here we can open up. I'll move it over here to the side. And then we'll make sure okay, so I got to change the marginal revenue equation or the perfect elastic demand curve to 15 minus 0Q. All right. And then marginal cost is slightly different. Let's just copy. This right here we'll copy this and I'll show you what happens when you copy this in. When you copy that in from IOpenMath, the quadratic term is gone. So I got to delete this Q2. I got to delete the 2. I'm going to hit Shift and the 6 button to Shift 6 is the arrow that points up. That allows me to square that Q, right? Which bends the curve forward like this, right? It bows it toward the x-axis, right? So now this is identical to that. Notice I use P here. I can't use 2 letters for one variable in Desmos. So I'm just going to go with P. So this is the marginal cost curve, and this is the perfectly elastic demand curve, which is also marginal revenue. So we got marginal revenue and marginal cost. Okay. Now, according to this model here, marginal revenue and marginal cost equal at this point. So at this point, the price is 15 because, again, this firm is a price taker, not a price maker, right? So its price is $15, right? That's the perfectly competitive market price. And the output is 180. Okay, so this level of quantity maximizes this company's profits. Now, if it competed against 22 identical firms, right? Each firm, which are equally bad at product design, customer service, innovation, right? They're all perfectly competitive and they're all selling what consumers consider to be identical products, homogeneous products, right? Then together, these 22 firms will produce what? I'm going to multiply the 23 firms. So there's 22 firms it competes against plus itself. Right? That's 23, right? And each of these firms is producing 180. So this is the 22 competitors, and this is itself. And each is producing 180 pizzas for a total of 4,140. Okay. Right. Now, suppose 5 years later, on a scale of 1 to 10, we're going to enter a number that indicates that the firm's marketing, product design, innovation, customer experience, etc., has become the best among its rivals and potential rivals. So if it's the best on a scale of 1 to 10, that's a 10. So down here, we have the same marginal cost curve, right? But now the firm is the best at all these tasks, right? And if it's the best, it is now faced with downward sloping demand, right? That effort determines the shape of its demand curve, which is shown here with its marginal cost curve. So now its demand, it's the slope of its demand curve is 0.05. And this curve is more vertical than it was 5 years ago. This is perfectly elastic. This is relatively inelastic. It's more inelastic than it was in figure 1. So it is more inelastic because perfectly inelastic is vertical, right? And this is not quite vertical. So it's more inelastic than it was in figure 1, right? So let's hit enter here. Okay. Now, when I hit enter, notice what happens. The difference in these two curves is average fixed cost, right? And as quantity gets closer and closer and closer to infinity, the difference in these two curves gets closer and closer and closer because the fixed cost divided by the quantity gets increasingly close to zero. So this top curve is the average total cost curve, and this bottom curve is the average variable cost curve. And the difference between the two is average fixed cost. All right. And this would be the marginal cost, right? Now, the scenario figure 2 represents the situation that the firm is in now. If it does not change its price and it's still charging $15, what's it going to do? Well, you can kind of tell here, right? If the price is $15, that's where its demand curve crosses its marginal cost curve or its supply curve, right? So I'm suspecting that it's the same as it was up here, right? I'm suspecting it's the same as it was up here, 180. Okay, so what we're going to do is we're going to tilt the demand curve. We're going to copy this, the number, and we're holding everything else constant, right? All we're doing is we're tilting the demand curve because they got really good at marketing, product design, and whatnot, right? We're going to tilt the demand curve now. See that? So if it keeps its price at 15, right? If it keeps its price at 15, it's still going to sell 180 units. Right? It's going to sell 180 units at $15, right? And notice that if revenue is price times quantity, then this box here from the dashed line down and this dashed line to the left, that box is revenue, right? And this is right here, this curve is average total cost, right? At this quantity, average total cost equals price. So if you take price 15 minus average total cost 15, right? That's our per unit economic profit, which would be zero. And if we multiply that per unit profit, economic profit by, if we multiply that zero per unit economic profit by the quantity, zero times any quantity, well, 180 units would be zero. So our profit is going to be zero here, right? But what we're going to do is we're going to plug these numbers into our total cost curve, right? So first we're going to calculate the revenue. And the revenue is just price 15 times the quantity 180. And what I'll do is I'll get rid of this is our revenue, 2,700, right? 2,700. Okay, and then this down here is our total cost. Is our total cost. Okay, now I got to be careful right here. I got to change this from Q2, Q raised to shift 6, raise the second power. Then I got to change this right here, this Q3. I got to change that to Q raised to third power. So I'm going to press shift 6 and then type 3, right? Then what I'm going to do is I'm going to do this. Oops. I did the wrong thing here. I'm going to press enter here. I'm going to do Q equal to 180, right? I'll change this to Q. And I'll change this to Q. Right? So my Q is 180. This is what the 23 firms total produced before this firm becomes a monopolistically competitive firm. This is the revenue because this is the price, right? And notice that my quantity here, or my total cost, this total cost equation ends up being 2,700 too, right? So my total cost is 2,700. And then my profit, my economic profit is the difference in these two, which is zero, right? So this firm, which has this great marketing, great product design, great customer service, is charging the same price as all the competitors. But firms value, or people value all that stuff, right? When you have great marketing, people are willing to pay a little extra for it, right? So if it continues to charge the same prices it did before, it's going to generate zero economic profit. Instead, suppose the firm decides to capitalize on its industry-leading marketing, product design, innovation, and customer experience by reducing output just enough so that its marginal cost just equals its marginal revenue. Now, remember that this firm, this monopolistically competitive firm, is now faced with a downward sloping demand curve. Now, because it's faced with a downward sloping demand curve, it has a downward sloping marginal revenue curve. And remember that marginal revenue curves of a monopoly, or when that price is like a monopoly, a monopolistically competitive firm, the marginal revenue curve has the same intercept as demand, right? It has the same intercept as demand. So 24 is the intercept. It has the same intercept as demand, but it's twice as steep, right? What is twice as steep? What is 2 times 0.05? Well, 2 times 0.05 is 0.10, right? So we have this downward sloping marginal revenue curve now, right? Okay, so now I got to put it in here. So P equal to 24 minus 0.10 Q. That is the new marginal revenue curve of the firm. Now I'm going to click on the gear here to change this to red to match my graph, right? To match this graph. Okay, so what is going to happen here? The monopolistically competitive firm is going to restrict its output, right? It now maximizes profit. This isn't profit maximizing because this is the marginal cost curve equaling the demand curve, right? The price along the demand curve. That doesn't maximize its profit. Its economic profits there is zero. So it maximizes profits when the red curve, marginal revenue, equals the black curve here, which is marginal cost. And it's going to restrict its output to 120.451 pizzas. Okay, so it's going to restrict its output to 120.451 pizzas. So right here is where marginal cost, marginal revenue intersect, right? So right there, it chooses its output. And then by restricting its output from this value to this value, it can now make the price, make its price in its niche market. It can restrict its output and push the price up to the demand curve, which looks like it's roughly 18, maybe 18, right? So we go over here to the graph. The quantity, the monopoly quantity is 120.451, right? I'm going to change the color of that to black, use a dotted line, and change the thickness to 1, and click done. Okay. So on the demand curve here, Okay, the marginal cost of producing 120.451 is $11.96. But because this firm has created a really good marketing program, has excellent customer service, et cetera, is the premier in this industry, it can charge a price up to the demand curve, up to its new downward sloping demand curve, which is 17.98. Now, its revenue is this box here now, right? That is at this monopolistically competitive price, almost $18, right? So its revenue is this big box here, right? It's this big box, price times quantity. So its revenue is the price it's charging, 17.98, times that quantity, 120.451. So its revenue is $2,165 and $71. Okay. What I'm going to do is I'm going to change this to Q. I'm going to change that to Q there. And then I'll change this to Q. Okay, so this is the revenue, the price times the quantity, right? Price times quantity. Okay. Now, because I changed this to Q, this quantity here to Q, the monopolistically competitive firm's output is 120.451, right? Well, when I change this to Q, it automatically substitutes that Q into here, right? And its total cost is $1,900, $907, $1,907.99. Okay. So what's going on here is at this output level, where marginal revenue equals marginal cost, average total cost looks like it's about 16. The monopolistically competitive firm's price is about 18. So it's making about $2 per unit in economic profit. That's the height of this dashed line box, right? So this height is the per unit economic profit. Multiplying that height by this width gives us the area of this box that is surrounded by these dashed lines. And this box is the economic profit of this monopolistically competitive firm, right? So the profit is the difference in the revenue, 2165.71, minus the profit, minus the cost, total cost, $1,900.07.99. So the monopolistically competitive firm's profit is $257.72. 72 cents. Okay. Now, this is 5 years later, right? 5 years later, what's going to happen is it can generate this profit in the short run. But because it's generating this profit in the short run, a firm that maybe is currently perfectly competitive will see that this firm has above normal economic profit, a positive economic profit. right? Above normal economic profit, right? So what that competitor will do is they're going to try to replicate what this firm is doing. And if successful, the firm will enter this firm's niche, right? There'll be two firms in this niche. And what will happen is this box over the long run, over a long enough period of time, this box will collapse down to zero height. Eventually, the average total cost will equal the price of the monopolistically competitive firm, right? This box will disappear.